Okay, I'd like to go over what makes our solar system so unique. It's like no other solar system that we've found so far. And the fact that our solar system is so unique, it has incredible ramifications for human history as well. So here you have in front of you a model of the solar system with the planets in order, starting with the Sun, which isn't a planet, on the left. Then in order, we have 4 inner planets, the small ones: Mercury, Venus, Earth, and Mars. And then we have the big planets: Jupiter, Saturn, Uranus, and Neptune. Please note that you can see the asteroid belt between Mars and Jupiter. It separates the smaller inner planets from the outer, bigger ones. It had always been scientists' contention that our solar system was a likely model for all the rest of the solar systems we would later find. Scientists expected that once we found other planets and solar systems, they would be just like ours. That was the expectation, not the reality. Scientists believe this is the way solar systems would form. Small rocky planets on the inside, close to their sun, and large, big gaseous planets further away from the sun. It was expected this is the way all solar systems form, just like ours. But that's not the case, and it completely overturns everything that we know about solar system formation. And about ourselves as well. The first planets outside of our solar system surrounding another star were first discovered in the 1990s. And as technology advanced, we began to find more and more planets around more and more stars. With the aid of technology, we've found almost 4,000 planets around 2,000 different stars. So we have a good idea of what the typical solar system looks like. And the typical solar system looks nothing like ours. What you have in front of you right now is a NASA model of one solar system called the TRAPPIST-1 system. This is the typical solar system. What you find are all the planets are about the same size, and they're all very, very close to their star. Remember, scientists had thought solar systems would have small, rocky inner planets and then large, big, gaseous planets on the outside. It's just not what they found. Like, here's the TRAPPIST-1 system, as I noted before, and that's a model. This solar system is nothing like ours. And in fact, this solar system is the typical solar system. Almost every solar system we find is like TRAPPIST-1. All the planets are the same size, or about the same size, and they're very, very close to their star. They're not far away. In this model here, all of these planets are closer to their sun than the Earth is. And as you can see, there are just no small, inner, rocky planets. They just don't exist. So we found almost 3,000 solar systems. None are like our own. The one that is closest in kind to our own is here, the Kepler-90. You see the Kepler-90 here modeled at the top of this photo. And even though Kepler-90 is the closest in kind to our own solar system, it's still very much different from our own, and it has no inner rocky planets. I just want to go over a comparison of these two. You see the Kepler-90 system on the top, and what you see is essentially 6 somewhat smaller planets. And then there are 2 larger planets as well. But what you see is they're generally within the same range of size about. Especially when you compare it to our own solar system, which you see modeled on the bottom of this photo. The bottom left of the photo, you see our four inner planets. It's Mercury, Venus, Earth, and Mars in order. Look how small they are. Compare them in size to the inner planets of Kepler-90. There's no comparison. We're so much smaller. Particularly, look at the first and fourth planets, Mercury and Mars. They're just little tiny dots compared to the Kepler-90 planets. Something happened in our solar system in its past that makes our solar system very unique from other solar systems. And now I'd like to move on to a great scientist passed away a few years ago who nailed it in the 70s regarding what happened and why our solar system is so unique. He came up with his hypothesis in the 70s and he nailed it. That scientist's name is Thomas Van Flandern. My source for all this information upcoming is from Wikipedia. Tom Van Flandern attended Yale University where he received a PhD in astronomy. So his credentials are absolutely impeccable. It was in 1976 that Tom Van Flandern began to promote the belief that planets sometimes explode. He promoted the idea that the reason our solar system looked the way it did was because of planets that had exploded in our solar system in the past. Now, this was long before we had the ability to see other solar systems and other planets. This is 20 years before we had that capacity, so we had no idea what other solar systems look like. The only solar system we knew about was our own. The fact that our solar system is so unique among other solar systems appears to support Van Flandern's idea that planets exploded in our solar system. Here's a closer view of the inner part of our solar system: Mercury, Venus, Earth, and Mars, the small planets, then the asteroid belt, and then Jupiter. Van Flandern proposed the idea that the asteroid belt was once a planet that exploded, and that's how the asteroids came to be. The planet exploded, and its broken remnants are now orbiting the sun as the asteroid belt. Now, I wanted to present to you some more information. Van Flandern had made predictions about his exploded planet hypothesis, about what we would ultimately find in the solar system. Those predictions all came true. There's 11 different points that he predicted. They all came true. The standard model that most scientists adhere to did not and could not predict these features of our solar system. And in fact, the standard model couldn't have produced the features that we have since found. Unfortunately, there's a copyright issue. I wasn't able to present that here. I don't want to even bother to try because Cambridge wants you to pay for the ability to utilize any citations from this article. But I encourage you to either go to cambridge.org or do a search for Cambridge Tom Van Flandern. You'll find an abstract of the paper that he did, Tom Van Flandern, where he cites 11 different points that we found in the solar system that, he made the predictions we would find these in the future. He made these predictions, I believe, in the 70s, and in the 90s and 2000s we proved him right. So it appears that Tom Van Flandern's exploded planet hypothesis is exceedingly accurate. Unfortunately, it takes mainstream science about a generation or two before they actually acknowledge things and catch up with reality. That's just the way it is and the way it always has been. Scientists and professors, they teach, things for decades and years, and then if they're proven wrong, they've been teaching students and giving doctorates out to people for decades based on incorrect information. Most professors aren't willing to acknowledge that. So new information often takes a while, but I can assure you this is beyond reproach. The exploded planet hypothesis appears to be very, very accurate theory about how our solar system came to be, in particular because it's so unique and so strange. In the future videos, I'm also going to talk about that exploded planet that is between Mars and Jupiter, the asteroid belt. We believe that there was a civilization on that planet. It wasn't an accident that the planet exploded. It was a matter of warfare, and that planet was destroyed. And it appears that that isn't the first time that has happened in our solar system as well. We believe that at least, aside from Earth, we believe that there have been at least 2 other planets that had civilizations in our solar system, and both of them destroyed themselves. So that's a warning to us, and what could be a potential future unless we get our act together and figure out how to live amongst ourselves and other life forms in peace. So thanks for watching this. I'll be posting more videos that will continue this theme and enlarge upon it. This information doesn't come about out of the blue. There's a whole load of supporting information that will change the way we view ourselves and our solar system, our civilization, and everything that we know. Thanks for listening, and everybody have a great one.